So we have Algebra 1, Chapter 3.2. We are going to be solving equations by graphing. We're going to solve linear equations later on, especially when you get to Algebra 2. We'll talk about other types of functions, because all functions can be graphed, and then you can look for solutions. But before we get to all of that, we have to kind of go back through some of those definitions, some from yesterday, some things that are new. So, I think we talked about yesterday what a linear equation or a linear function is, right? We said it was a function for which the graph is a line. Okay? That's something we talked about yesterday. Today, we got 4 different new ones here. And I actually kind of like this whole idea of the parent function being introduced right now. And parent function, guys, in the second part of that, it says that is the most simplistic linear function. Right there. And it happens to be f of x equals y. Or, if we don't like that, guys, isn't that just as saying y equals x? So it means if x is 5, then y is 5. If x is negative 3, then y is negative 3. Okay? So y and x are the exact same thing. Guys, this would be what we call a parent function of a line. It's the most simplistic, easiest line to ever have. Okay? But then we move down a line here, and it says a family of graphs. Here's the cool thing about a family of graphs. A family of graphs, guys, is a group of graphs that have one or more similar characteristics. The cool thing about the parent graph and their families is that they look exactly the same. It's just that they're moved. You move them from where they start. So they're in different places. They all look the same, but they're in different places. So then what we got to talk about is the root and a 0. A root, not a tree root, but a root, guys. Does anybody happen to know what a root of an equation is? Some people may have heard that before. No. It's a solution to an equation, aka makes the equation what? True. So it has to make the equation true. That would be a root. It's a solution. And to be a solution to an equation, you need to make the equation true. So all of those things that you guys were solving for in 1-step and 2-step equations from last chapter, you were finding the roots, the solutions. And we can also, here's the cool thing, guys, the roots, the solutions, the zeros, which is the last one, they all stand for the same thing. Because zeros, guys, are the values of x for which f of x equals 0. It's when you plug the value in for x, it makes the equation equal 0. And there's going to be a reason why we say that they are all the same. Because when I start to graph my equations, I'm looking for what makes it 0. What x values make it 0. But remember, f of x is the same thing as y. So it basically is saying, where does y equal 0? What x values make y equal 0? But wait a minute. I don't have it up here, but wait a minute. When do we ever have a set of points that have 0 for y? We talked about this yesterday. Luke?
0,
0, 0, okay? Or 5, 0, 10, 0, negative 5, 0. Chuck? Which ones? The x-intercepts, right? So we also, guys, they don't have it listed here, but I think it's a good place to talk about it, is the fact that a 0 is the x value which is the solution to an equation, which is the root, because it makes the y equal 0. But that means that if y is 0, then it means on a graph, it's actually the x-intercept of the graph. So like 4 different things are being combined to all say the same thing. They're interchangeable. I may ask you, what are the zeros of that equation? What are the intercepts of that graph? What is the solution to the equation? They all mean the same thing. Okay? Okay, we're going to take it real simple here. We're going to solve equations with one root, one solution, guys. Solve the equation algebraically. So I just want you guys to solve these ones algebraically. The next slide, we're going to do it graphically. So look at this. There's only one variable. There's just x. Can you solve for x? Every single one of us should be able to say yes, because we did that last chapter. So 0 equals 1/3 x minus 2. What do I need to do first? Maddie? Oh, I thought your hand was up. No, we're not going to put it into standard form. We want to solve it.
Oh.
Kathy? Add 2 to both sides. I'm going to add 2 to both sides. So I get 2 equals 1/3 x. To get rid of 1/3, I'm going to multiply both sides by what? Not 1/3. By 3 over 1, or 3. Because the 3 and the 1/3 cancel each other out, I get x equals 6. And the cool thing about it is, that's my solution. I can check it. Plug it back into here. What's 1/3 of 6? 2. And 2 minus 2 is 0. It works. I checked it. We're good to go. Right?
Right.
That's solving algebraically. Not a big deal. Guess what? 6 is a solution to the equation. Yeah? But it's also a 0 of the equation. Why? Because when I plug in 6, it equals 0. Awesome. I'm going to give you guys a couple seconds to solve the next one by yourself. Okay, hopefully we have an answer by now. If I want to solve for x, what's my first step? Joe?
First step would be to get rid of the 1.
And how do I do that?
Subtracting
Subtracting 1 from
both sides.
both sides. 3x equals -3. Logan?
And you divide 3 on both sides.
Divide both sides by 3. So were we able to get the answer of -1? And of course, if I check that, plug it in, what's 3 times -1? -3 plus 1, -2. Does -2 equal -2? Yes. So guys, that should be no big deal. We've done this already. That's old school. The reason I'm showing you this is so that when we do the graphical method, you also have another way to back up your answer other than just checking. We can solve things algebraically. We can do things graphically. Can I turn the page?
Yes.
Anybody else want to let me know if we can turn the page? Okay. So, I have a few steps here for solving graphically. The first step I want you guys to do is I want you to solve the equation equal to 0. That means bring everything to one side. Sometimes, like part A there, it's already done for you. Other times, it's not. I want you then to replace the 0 with f of x, or y. Yes. Because that way, I now have an equation that I can solve, or graph, sorry, by making a table with a few points. Right? You only need a few points. Sometimes more is better. Once you find those few points, you're going to plot them, draw your line, And then in step 5, to solve an equation graphically, you are looking for where does the point, or the x value really, of where the graph crosses the x-axis. Basically, an x-intercept, which then tells you that the x value leads it to be equaling 0 for y, which what we solved it for originally, right? Y was technically equal to 0 before we replaced it with a y. Are you seeing how that's all kind of connected there? I set it equal to 0 to replace it with a y. So y is technically equal to 0, which then says I solve it for the x-axis, where it crosses, which is an x-intercept, which has a y equals 0 and a value for x, which is the solution or the root or the 0 of it. So many things connected. So look, I started off with a nice easy problem, and then I ramp it up to something that's not so nice. So the first problem, part 1, is already done for you. Yes? Can you guys agree with this? Mm-hmm. So that means we go to step 2, I take the 0 out, I put in what? F of x, or if you feel more comfortable, replace it with a y. Because we make an x, y table or an x, f of x table. It doesn't matter, it's a function, okay? Step 3 says let's make that table. It's x. I'm putting the equation in the middle. Right? Again, because I get to choose my values going in, and we're talking about lines, guys. Lines go on forever, right? So therefore, I'm going to choose 0. I can choose anything I want. What happens when I put 0 into this equation? 2/5 times 0 is? What's 2/5 times 0? What's anything times 0? 0. And 0 plus 6 is a 6. That makes sense? Someone else give me another value they'd like to choose. 1, okay. If I put in 1, I will have 2/5 times 1 plus 6. 2/5 times 1 is 2/5. 2/5 plus 6? 6.4? Oh, geez. That doesn't look so nice, does it? Hey, guys. If I really got to choose what value I wanted to put in for x, what would actually be a really nice value to put in? Now, why 5? Right. What happens when I multiply 2/5 times 5? The 5s will cancel. This is where your number sense, guys, comes in handy. For the fact that the 5s will have to cancel each other, leaving me with 2, and 2 plus 6 is 8. What would also be another nice number then to put into there, if we chose to? 10 would be another one going the other way. -5, -10, because those numbers are all divisible by 5. Pretty cool stuff, right? So, let's just stick with these 3. And let's graph them now. Notice that I did not choose anything in the negative quadrants. Yes? Yeah. So I need to go all the way up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And going up to 5. 1, 2, 3, 4, 5. Notice I'm trying to keep my lines as straight as possible. I'm trying to keep my intervals as uniform as possible. If it works better for you to use graph paper, please do so. Okay? Now, let's graph it. 0, 6 is there. 1, 6.4. That one's going to be an interesting one, huh? Yeah. Someplace like there. Maybe a little over further. And then 5, 8. 5, 8 is there. So maybe that middle point needs to be over a little bit further, right? But here it is. You guys got to solve that graphically. Where's it across the x-axis? That doesn't look fun at all, does it? That's way over here. This comes way, 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 way over here. It's not even part, it doesn't even fit on my graph. So it's probably even further than 9, right? And if anything, can you tell my line might be a little bit steeper than what it should be? You'd almost think that the line should be a little bit more there, because I'm hitting like the top of the point here and the bottom of the point there. So it's teetering just a little bit more of a steeper line. So man, that's not cool. How can I fix that? I'm going to pause the video and I'm going to erase that and we're going to redraw it. Okay, what if I restarted and I chose to go by 2s? So this is 2, that's 2. Maybe this helped? Notice that I left a little bit more space in the second quadrant because that's where the answer is going to be, right? So if I go, that'd be up 2, 4, 6 here. And if I make it at 5, so it'd be 5, whoops, 2, 4, 6, 8. Should be about there. Right? Okay, so I'm going to tries. I think the 8's too low. Try it again. Better? Okay. And then something like this. So remember, we're going by 2s, right? Now here's the question. I just redrew this, and I think we still could assume that this is probably not the most perfect graph you've ever seen, right? So when we go to solve these things, are we going to come up with the right answer by graphing every single time?
No.
Probably not. Will we be in the ballpark at least, hopefully?
Yeah.
Yes. So therefore, that's why we're also going to want to check these algebraically as well. So, if this was the case, that means this is 2, negative 4, negative 6, 8, negative 10, 12, 14, 16, 18, 20? Can we say that it crosses at negative 20? So we would say that that point would be negative 20 comma 0. Or we would say that, hey, we found our answer to be at x equal negative 20 should be our solution. That's what we're saying on our graph. Here's the cool thing about the graphs, guys. I'm not going to ask you to re-graph it if you're wrong. How do I know if I'm right? What's that? Check it. And I check it by placing it where? In the original equation, guys. So, let's check it. 0 should equal 2/5 times negative 20 plus 6. What's negative 20 divided by 5? Negative 4 times 2? negative 8 plus 6, and that equals negative 2. Is it correct? No, it's not correct. So negative 20 is not correct. Guys, this is what I would like you to do. I would like you to tell me negative 20 is not the solution. Cross it out. This is telling me a lot of information. It tells me that you know how to set up a table, you know how to plot points, you know how to draw a line, you know to look for an x-intercept. It's just that your graph was not very accurate. That's all okay. Now, what I might want you to do is not redraw a graph, because again, you're just going to redraw it probably just as inaccurate as the first time. What I would like you guys to do then is solve it algebraically. Tell me what the answer should be. So if I go here and cancel some of this out of here, 0 equals 2/5 x plus 6. Let's solve it. How do I solve that? Subtract 6 from both sides, so negative 6 equals 2/5 x. Last step then would be multiply by 5 over 2. So these cancel each other out. I'm running out of room. X is equal to, what's 5 times negative 6? Negative 30 divided by 2? Negative 15. So the real answer should be negative 15. Were we kind of close? I think so. Because look how far back we had to make our graph just to make it cross the x-axis. We very well could have messed up. I mean, I think you can see my line's not perfectly straight either. So, let's just recap here. You were going to graph the equation by setting it equal to 0, setting it with f of x, making a table, plotting it, looking for where it crosses the x-axis. You then check your answer. Am I right? Am I wrong? And if you're wrong, let's do it algebraically to find the real answer. And we have it. The last example, I think, nope, we got one more after this, is what happens if there's no solution? What does it look like algebraically, and what does it look like graphically?
It's non-linear.
No, this one's still linear. So there is actually options when it's non-linear with no solution as well. But let's solve this algebraically. Well, what do we have to do? To solve this algebraically, you get the x's on the same side, yes?
Mm-hmm.
So, what do I have to do?
Subtract 3x.
Subtract 3x. You got to get to one side to the other. So let's bring them to the left side. Oh, wait. These we engineered to cancel. But then we engineered, wait. This side was supposed to go together. But what happens here, too?
It's not.
They cancel each other. And you get 7 equals 1. Is that ever true? Didn't we talk about that once before?
Yeah.
Or, wait a minute. If I subtract 1, isn't that 6 equals 0? Is that ever true?
No.
So there's no solution. Algebraically, they don't jive. No solution. That's easy enough. We've dealt with that before. We've had that problem before. What does it look like graphically, though? Using that same process, right?
Oh, wait, the lines. No.
I have to bring everything to one side, right?
Yeah.
Which means, again, set it equal to 0. So let's just subtract 3x, subtract 3x. So 7 equals 1. Let's subtract 7. Oops. So now 0 equals negative 6. Is everybody okay with that? I set it equal to 0?
Yep.
But then I'm supposed to take the 0 away and make it with an f of x equals negative 6? Or y equals negative 6? Does anybody know what y equals negative 6 line looks like? It's a horizontal line. But, hey, we didn't know that. Let's make a table up then. X y, or f of x, and negative 6. 0 goes in, what comes out? Has to be negative 6, so it's negative 6. If I put in 2, it's negative 6, which is negative 6. I put negative 2, it's negative 6, it's negative 6, yes? The answer is always negative 6. So what are my points? My points, 1, 2, 3, 4, 5, 6. 0, negative 6. 1, 2, negative 6. Negative 2, negative 6. It's a horizontal line. You tell me where that horizontal line will cross the x-axis. Never. So if your graph turns into a horizontal line, it'll never cross the x-axis, which means there's no zeros, there's no solution, and there's no roots. Craziness, right? So the last problem we're going to talk about is what happens if they give you a word problem and then have you guys solve things. And what does it mean in the context of the problem? It says Tony's class is selling candy to raise money for a class trip. How nice. They pay $45 for the candy, and they are selling each candy bar for $1.50. The nice thing about it is they give you the function. The function y equals 150x minus 45 would represent the profit y when they sell x candy bars, right? Every candy bar they sell, they make money, but you have to, at the end, take away the cost of all those candy bars, right? That's why you got minus 45. It says find the 0 and describe what it means in the context of the solution. Hey guys, are we going to solve this algebraically or graphically? It'd be easier to do this algebraically. Graphically could take a while. We'd have to set up a big table. So, because again, you got 45 to make up, right? Selling $1.50 a piece. But anyways, so that means I have y equals $1.50 x minus 45. If I wanted to solve that algebraically, I'm going to take the y out and put a 0. I want to know when does it hit 0, right? So 0 equals 150x minus 45. And every single one of us should be able to say, hey, I can solve this no problem. Carson, what's the first step?
Minus 45.
Not minus 45, but add 45 because we got to do the opposite, right? So 45 is equal to 1.5x. Gus, what do we do now? Yep, divide by 1.50, or just 1.5, really. So I get x equals what? What do I get? Is it 30? So I get 30. The 0 of the problem is 30. But that's great. We found it. Now describe what does it mean. What does it mean when I sell 30 candy bars?
Means you're going to make some pretty good money.
No, it doesn't mean that yet. I'm going to break even. You guys notice that this is the break-even equation? At this point, when I set it equal to 0, it's when does the profits equal the expenses, or the, not the profits, but the money coming in equal the money going out? That means they need to sell 30 candy bars to break even. Soon as they sell over 30 candy bars, which I'm assuming as a class you should be able to, they'll start making money. Makes sense, guys? That's how you read these types of problems. Homework is on page 166, 10 through 43, every 3. Have a fantastic day.